Good afternoon, everybody. I'm going to probably speed through this because there's a lot of overlap with Daniel's talk. So hopefully I can gloss over a lot of the stuff that he's covered in detail. And I'll just kind of go through the highlights of basically integrating that UEFI secure boot into OpenXT. And the title of the talk is with the implications about the anti-evil Maid. So we'll talk about how we can provide those guarantees using SRTM and DRTM. All right, just an overview. We'll go through why we're doing it. Background, as far as UEFI, I'm probably going to skip that because we just had a nice coverage of it. What we have to kind of provide is proof that anti-evil Maid is not, we're basically protecting against the evil Maid attack. How we extended the SRTM chain to cover each piece of the boot process for OpenXT, and basically all the implementation details that we worked on along the way. And finally, we'll talk about the DRTM in respect to OpenXT with UEFI included. So I'm pretty sure everyone now is familiar with OpenXT. So basically, it's security hardened Zen client distribution. And as of probably 6 months ago, there was no UEFI support, which is starting to become a problem because there's really not any BIOS support out there for newly shipping hardware. It's getting harder and harder to find. All right, this is all background stuff I'm going to skip over. So we talked about the shim. Essentially, it allows us to use secure boot and establish that SRTM. But it's really tailored towards Linux, and we're relying on Red Hat to provide that implementation. So there's modifications that we have to make in order to use Zen with respect to that. We have a little bit different of a scheme than what Daniel was talking about. So we don't actually load up GRUB. We'll go ahead and we'll have the shim load Zen measure and then move on from there. So this kind of jumps into how do we prove. Okay. Basically, the pieces of the proof that we need to go ahead and say that, yes, we're pretty safe against the evil Maid attack. We got to authenticate the user to the computer, the software to the computer, and the computer to the user. So that kind of goes into that as to say what we're doing, do what it's actually saying it's doing, and proving it. So for the most part, I would say that the stronger option is definitely going to be using remote attestation. It's not always available, but we get our measurements in the DPM, we know we're in a good state, and we move on from there. We check that we have our sealed secrets correct. Okay, and this gets into the SRTM and DRTM. So static root of trust, I think it's very convenient. It does make life kind of easier now that secure boot's in there. So anything we can add to go ahead and leverage that to provide extra security, it's well worth it. So. Okay, and the DRTM, which we've been relying on for a while in OpenXT, there's always been that kind of looming, yes, the STM is something that we'd have to worry about. Like, we need that to provide a good assurance as to a measurement of system management mode, which we kind of don't have outside of the kind of theoretical pieces out there right now. So until the OEMs start to support it, it's a hole that we have to include almost the entirety of firmware in the TCB. And the SRTM is in that same boat, where we do have to trust the firmware. So this slide kind of goes into showing basically where each piece that's measured, what PCR gets loaded into. So it's kind of a handy diagram as to what each piece is measurement ends up sitting when you're checking out your measurements in the DPM. So the SRTM chain in OpenXT, basically we went through a couple of phases of establishing that. So these are all the things that we definitely need to measure to get started to cover basically the entire boot process to get to a trusted state. First go at it was, let's just bake everything into the actual images. So we'll go ahead and take your boot options, your Flask policy, and we'll build that into the binary. Same thing with your Linux kernel. We'll go ahead and build all of our kernel options into the binary, and we'll also build in our initramfs. So there's big giant binaries that we load up. We only have to measure those, and that's it. So we kind of went through that. There's a little bit of a problem. So we can go through that, and it kind of works. The issue being that basically both Zen and Linux, if you provide any command line parameters, even if you bake in command line parameters to your kernel, if you add it to your options for the kernel, the last one that goes is going to override it. So if anybody goes ahead and modifies your GRUB config or something along those lines, they can either change your initramfs or basically provide a last-minute change to the chain. So also initially, Zen did not just boot off the bat from the shin. There was a relocation problem where essentially the shin would mark some pieces of the binary as relocatable, and Zen didn't like that. So there was a little bit of failure there that Dr. Tom ended up correcting. Also, there was a couple of platform-specific issues where we'd have a platform that would kind of fail silently and would not report that the measurement had failed. So that's definitely not good. So essentially this was on a particular Dell machine. So our friends at Dell, maybe you can take a look at that and get that fixed up. But there's basically a fallback option now to essentially ensure that that's taken care of. Yeah, so just details on that patch. So I kind of went into this, but yes, if you built in options and then you can override them as it's going to take the last loaded pieces of those options. And being that those aren't measured at that point in time, you can end up getting subverted. So after we kind of saw that and the fact that baking everything in doesn't solve any of our problems, we kind of went back to the drawing board, decided to probably fix things the more thorough way. And this seems like a very basic idea, but yeah, measure everything. And measure, like, from the get-go, we probably should have went down that route, but either way. So essentially we added some protocol piece so that it's a little bit more accessible in the shim. So later on, Zen can call in there and go ahead and try to measure different pieces. Pretty small patch, and it has that workaround as far as authentic code signatures. And I think these are still in waiting to see if Red Hat's going to accept them, but the pull requests are up. And then this is in the Zen EFI start, actually calling back to measure the config itself to ensure that all those command line parameters haven't changed. And measuring the XSM policy and the initRD. All right, so we've got most everything checked off there. That's being measured and making sure the measurement passes before we go ahead and move on and execute the next piece. So we have to essentially we have our initramfs, we're still trusted, and we have to make sure that our rootfs has not changed, and we can trust that. And this is a relatively simple thing to do, to basically go ahead and measure that rootfs before we mount it and switch root. Read-only rootfs makes life a little bit easier in this respect. You have some notional idea of that your rootfs is not going to change during runtime. You don't have to worry about updating that measurement as the system is running later on. So you want that kind of overlay file system to say that programs can write to something, but it gets tossed out, so there's no state. And next time you boot, that measurement for the rootfs is going to be the same. All right, so that covers all the pieces that we were talking about measuring. Where'd that slide go? I don't know where that went. All right. As far as an SRTM goes, so all that is integrated into OpenXT right now, and all that those pieces are up and working. We kind of had a discussion as to whether that was sufficient, and I think that the remote attestation piece is important. So you could swap out someone's laptop with OpenXT and go ahead and give them something that looks exactly the same and has that green check mark, and then they'll start maybe entering their credentials and stuff like that, and then you could swap it out again so that you had access to their system. So I think that it was brought up yesterday, but the TPM, TOTP, or something along those lines for that scheme to have some remote attestation, whether we're kind of talking about providing maybe a QR code that maybe gives you an idea of what your measurement is at that time. And you can maybe register that during an install with your phone or something like that. So that's something that's not implemented, but I think that that would provide a nice extra bit of comfort, a little bit further than just the green check. Okay, so one piece that's a little bit different here than what Daniel was doing is that we're not using GRUB. The boot chain is getting pretty long for a lot of these schemes. So we essentially have foregone GRUB at the moment. It's not to say at some point in the future we might not just go back and use that if it ends up providing any convenience. But if we don't have to introduce any extra code to run, I figure we'd keep it out until then. Another piece is EFI has location for putting options in. So Thomas put together a patch to go ahead and actually have those sit in EFI RAM, NVRAM, so that instead of having that config, just that text file with all that information in there, we actually use the UEFI blessed way of putting those options in. So that is actually up for review right now. And I think I don't have an updated status on that, but the patch is up on the mailing list and it's being reviewed. All right, now we did all this work on the SRTM, but we ended up that we didn't have the DRTM, and we do need that. There's kind of no way to get around that. So it's kind of a complicated scheme, but actually thanks to Daniel, provided us with a lot of help on that. But yes, you had the shim. The shim launches Zen. Before Zen actually loads up the hypervisor, when it's still in EFI start, it'll go and measure tboot, load that up, and then tboot will go and load that same binary into a different piece of memory. So you have Zen loaded up in two different spots, and one will kind of just be unused. It's a lot of code to be loaded up to do that, but it does provide a quick and dirty way to get tboot up and running in EFI. And yes, the multi-boot struct was kind of handcrafted. And so, like I said, SRTM stuff is all merged. The DRTM is up there. It's been up there for a couple weeks now, and it's under review. The shim patches are under review. It would be nice to see those get merged and actually rolled into the release for Red Hat's sign shim so that we don't have to sideload keys, which would make life a little easier for deploying some of this stuff. And then up there is Thomas's kind of sandbox area of all the code that he was working on. But for the most part, it's not out of date, but everything that's in there that's going to be upstreamed, which is pretty much the entirety of the work, is on the mailing list sitting for review or in progress to be merged. All right, if you have any questions.
What's the motivation for using the IAM infrastructure over something like DMVerity, since you have a read-only root file system?
I don't know what the motivation there was. I can certainly pass that question on to Thomas, but I would say that I think at that point, once you are in that position, picking whatever scheme you want it's fairly easy to swap in and out. So, I mean, I think that's probably just choice. I don't think it would be hard to support both and have that as a build time option or potentially as a runtime option. That's something I can pass along.
So that in test side DMVerity has significantly lower performance impact than the integrity measurement.
Okay.
Yeah, and it gives you similar cryptographic signatures.
Yeah, I'll definitely pass that along.
Have you built any support for remote attestation with the integrity measurement architecture, or is this just signature checking?
Right now, that piece is just signature checking. The DRTM does do measurements, but I think that's something that we'd really like to get to. So I think it's an important piece, and I'd like to see that integrated at some point. It's kind of something that we've always just been like, oh, remote attestation is important, and then not work on it. But yeah, getting that added in there, I think, would bring a lot of value to the platform.
There's also some patches that were posted recently for FS-Verity instead of DMVerity. DMVerity is like a block level, and FS-Verity is somehow integrated into ext4. There's ext4 encryption, but this has integrity on a file or directory basis. I'm not super familiar with it, but if you were trying to strike some trade-off between still getting the measurements but being easy to develop with, it might be worth it.
Yeah, that sounds good.
Consider just taking parts of TBoot and just incorporating them into Zen, because there's a lot of code which ends up being overlapped between the two. You know, all of the gathering of CPUs and then bringing them back up again. It's actually, certainly when we looked at this kind of thing in the past, it's just easier to make use of TXT directly than to actually try and use it and ship like TBoot, which you probably don't control.
Yeah, I don't disagree with that. I think that makes a lot of sense. I think that, I mean, this scheme is a little convoluted, having to load Zen twice, and where TBoot ends up living, whether it ends up maybe at some point having a native EFI application, so that we can load that directly from the shim and have that load up Zen, or move the functionality into Zen. I think that either approach would be valuable.
So the real problem here is that EFI was done for that and was fixed. That creates the weird circumstance.
One of the problems that makes that hard to do trivially is that the SNIT has to be executed in 30 megabit. So it's really a whole lot easier for TBoot to be compiled than it is for TBoot to be compiled with 64-bit mode. And Zen is going to be compiled with 64-bit mode. So you're going to have a little bit of problem there. It's not something that can't be overcome. It's just not quite as easy as copy pasting the code.
Daniel, you got a question? This guy?
How do you go from T to then the file is not usable structure? Now, I don't think so. I suppose that we could done some tweaking with then the file.
Yes, there has been some tweaks made.
Currently, it is impossible to use example PFY with not. If you are talking about Zen upstream.
Yeah, I think the patches are up for it. And that's something that, as far as the upstreaming process goes, if you want to reach out to Thomas, he'd be the guy to talk to about those pieces.
I think that Maid would always solve that problem. Because, as I said in my presentation, in one of these steps, I changed the key header, which properly describes the layout and constructs the layout properly for key, also for multiple properties. So this will be solved in a solution. You don't need any extra patches to load ZenUEFI directly from the
Okay, yeah, that sounds good. I mean, if we can settle on one set of patches to use, definitely.
Another thing, I suppose that this after launching Zen continue, Zen does not have access to EFI runtime